This now is a formula that works for any regular polygon. We should put that. It says area of polygons. Really, it's the area of regular polygons. Let's make sure we remember what a regular polygon is. Just quickly with our notes, you should know this. You've learned it for a long time. But remember, a regular polygon, they have the same or congruent angles and sides. They're all the same. So this formula works for any regular polygon. So in that, it's going to be more than just all of those shapes we've done. This will be like the formula that will get us like a hexagon or an octagon, a decagon, any sort of regular shape. In fact, there's going to be a lesson where they're going to make up like crazy ones. Like you're going to find the area of a regular polygon that has like 42 sides, like 57 sides. It's not that hard. You just have a formula that you're going to use with it. So that formula is this, and it's got some new terms in here. So here's our formula. The area equals 1/2 A times P. And this lowercase a has a new word. It is the apothem. And then the P stands for the perimeter. So we need to like point out what is the apothem of a shape. To do that, we're going to draw a picture, and we're going to draw a regular hexagon with 6 sides. So 1, 2, try as best you can. Have it pretty big so you can label it. 3, 4, 5, 6, as best we can to have them all the same, right? It's regular. You don't need to really put those lines. It's just showing you that they're all the same. And then we're going to have a dot right in the middle, the center. And then we're going to draw some lines in this. This line that goes from a 90-degree, hey, I wanted to change the color of that. It goes from a 90-degree angle from the side to the center. So a 90-degree angle from the side to the center, that is the apothem. I have no idea why it's called the apothem. I should be a better teacher and figure out why they named it that, but sorry. And then we've got another line that is new to us here. It's actually not a new name, but it's new when it comes to these. From the center to, ooh, that's not different enough. We'll just go with black. From the center to an angle. From the center to the angle, this is the radius. Now you think, well, that's weird. Like, how does this have a radius? Isn't that for a circle? Well, you don't need to draw this next part, but the reason why it's called a radius is if you took that line and brought it all the way around, my drawing's terrible, but you get the idea. That would be the radius of the circle. Again, if I could draw better, you would get the idea, but if there was a circle that went all the way around it, that would be the circle's radius. So from the center, and you take this line and spin it all the way around in a circle, that line would be the radius of that circle. So then we also have the perimeter here. Remember, the perimeter is the sum of all of the sides. So we typically, though it's not a part of the formula, we have just one. When we talk about this, we talk about S for a side. So we have S equals 1 side length. So again, that's not a part of the formula, but we need to know a side length. So when this starts, we'll start with super easy ones where you're just plugging in the formula and then we'll start to have a little bit of fun. Because the boring ones that you can solve easily, those are no fun. So here's the boring, easy ones. Easy or simple examples. And this would be like numbers 11 through 16. They will just come out and tell you information. You do need to know the names of some of your polygons, though, so that could get interesting. But it would tell you something like a pentagon. And then in the pentagon, oh, this is our first example, they would say the apothem is 14. And then they would say one side length equals 12. So then you're just going to write out your formula. The area equals 1/2. What's the apothem? They told you already. 14. And then the perimeter. Well, you got to do a little bit of thinking. A pentagon has how many sides? 5 sides. And so if each side is 12, what would be the perimeter? 60. Again, we get the perimeter because we just did 5 times 12. Then you can throw that all in your calculator. Let's see. Half 14 is 7. 7 times 6 is 42. Times 6 is 420. This would be units squared. So that's simple enough. They basically just tell you everything, except you've got to figure out the perimeter. They'll tell you how many sides with the name of the shape. They'll tell you one side. You figure out the perimeter and you plug it in for the perimeter. It's not that hard. Once we get to number 17, this is where things get more fun. More fun examples. You could go difficult if you'd like, but I like to be more positive and say these are more fun examples. Now, we're going to round this answer. Actually, no. We will have this. Yeah, let's round this answer. It could be either way, though. They could ask you to round it. They could ask you to keep it in simplest radical form as well. Round to the nearest 10. And they're going to give us a picture. Whoa. And they're going to give us one side length. We'll go with, I don't know. Let's make it nice and round. 40 inches. All right. This is going to take some thinking. First off, let's think about the area equals 1/2 the apothem times the perimeter. We should already be able to get the perimeter here. What's the perimeter? 1, 2, 3, 4, 5, 6. 240. The issue here is, what is the apothem? We're going to have to figure out the apothem. That goes from the center to the side at a 90-degree angle. Well, to help us figure that out, what we are going to do is imagine and draw a right triangle here. So see how we're going to make this a right triangle? And then we should know this next part you don't need to draw is that really this right triangle is the same as this right triangle. And really we could divide this up because it's regular. Again, you don't need to draw these. You could draw this up into a whole bunch of these right triangles. So see how like this right triangle here is really the same as this right triangle. And we could take this and split it up into a whole bunch of different right triangles. You guys see what I did there? Right, we got to imagine that every time. Now I'm going to take this right triangle and I'm going to enlarge it here to help us find the apothem. So I'm going to write a larger version of that right triangle. And we're going to try to figure out how we can find different parts of this. So first off, this right triangle is half of one of the sides. So this right here would be 1/2 of a side, 1/2 S. And in this case, what would that be? 20. That still doesn't give us very much information. Right? I can't find out the apothem yet. Well, this is what people do to figure this out. Do you guys know how many degrees are there in a circle to go all the way around? We got 360. Okay? And so we're going to find this angle. And I'll come up with a formula to help us find that angle. And so if all the way around is 360, I could take 360 and split it up into, again, you don't need to draw this. And imagine like that this line here is gone. How many degrees would each one of these central angles here be? 60. Because that's 360 divided by the number of sides, divided by S, the number of sides, right? Okay, that gets us this big angle here. Well, once we draw this line, oops, not that line. Once we draw this line, doesn't it cut that big angle in half? Do you guys see that? So really, to find this top angle in our triangle right there, you do 360 divided by twice the number of sides. So in this angle, we should be able to figure out what it is then. Well, it's 360. 360 divided by not 6, but 12. That is 30. And now we've got a triangle. Now we've got a triangle that we know how to work with, right? Isn't that a pattern we're already aware of? That's a 30, 60, 90 degree triangle. So now what is this line? We should know like right away. That's 20 square root 3. That line is the apothem, 20 square root 3. Now you can just sit there and figure it all out. If they wanted it in square roots, then we could just leave that. Let's see. I need my calculator here. 20 times 240. It's going to get some giant number. 4,800. And then divide that by 2. We'd get 2,400 times the square root of 3. And then if they wanted that rounded to the nearest 10th, we could round it to the nearest 10th. So they'll ask it two different ways. They'll ask for it in the square root of 3, or I just found the square root of 3, and then I multiplied it. What am I multiplying it by? By 2,400. And then round to whatever they want you to round to the nearest 10th. That would be, let's see, this 2 keeps that a 9. 4,156.9. 4,156.9 inches squared. Now, eventually, they're going to give us a whole bunch of different ones. Like they could give us a 10-sided figure, 12-sided figure, and it might not be this same pattern. You might have to use trig ratios. For this lesson, you're not going to need to use trig ratios. Everything in this particular lesson will either be a hexagon or a triangle. But here's the thing with this, they might not just give you the side length. Let's talk about another one with a hexagon. And we're not going to do the whole thing, but let's just say, go ahead and draw hexagon again. They could, actually, we'll do this whole thing. It's not that hard to do. Let's say this was 7 square root 3. This is our second example in it. We got the apothem of 7 square root 3. So now let's try to figure out what the area is. 7 square root 3, we'll just leave it blank and write it as units squared. 1/2, the apothem they already gave us. But what didn't they give us? They didn't give us the perimeter. Well, again, we can zoom in on that triangle. We've already talked about this, how this is a 30-degree angle, and then this would be a 60-degree angle. This is 7 square root 3. If that's 7 square root 3, what's this have to be? 7. So if that's 7, what's the whole side length have to be? What is that? 14. And if that's 14, we can then figure out the perimeter. I don't know what that is. 14 times 6, 84. And now you can sit there and figure it out. We'll leave this one with the square root. 18 times 7 divided by 2, 294 square root 3 units squared. So see, they could give you different parts, and then you would go through and figure out like different aspects of that. Let's talk about triangles now. And in triangles, there's 2 different ways that we need to do these. They could give us, so now we're going to do it. So that before it was with hexagons, now we're going to do this with triangles. They could give us a triangle, and they could give us the apothem of a triangle. So like, let's say this is 10. All right. We're going to turn that into a 30 or into a triangle, and let's make this big part and figure out everything of this triangle is this, right? It's like an enlarged version of this. That's the 10. And in our big formula, we have 1/2 the apothem. We just don't know the perimeter. Let's figure out what this angle is. Look back in this one. What did we do to figure out this top angle? How did we know that this was 30? Look, it's right here. 360 divided by twice the number of sides. Yeah? Okay. So what's that for this triangle? Someone do 360 divided by twice the number of sides. How many sides does the triangle have? What up? What would that angle be? 60, right? Because it's 360 divided by twice the number of sides. There you go, 60. This is now 30. You guys see how this is working out? So if this is 10, what does this have to be? 10 square root 3. So if that's 10 square root 3, the whole part down here would be twice that. 20 square root 3s. All right? What would the perimeter be then? If we have 20 square root 3, 20 square root 3, 20 square root 3, how many square roots of 3 do we have? 60 square roots of 3. And then you can put it all together. 1/2 just 300 square root 3 units squared. And I've got another shortcut here with some of these triangles. Let's try another one with a triangle. And we're not going to do, this is with an equilateral triangle, and they give us one of the sides. So let's say that this side here is 10. We could do 1/2 the apothem times the perimeter, but finding the apothem here gets all weird. You could also just do 1/2 the base times the height. Again, what we're doing right now is for an equilateral triangle where we have a side. I didn't spell it right at all, but anyway, triangle when we have a side. This one is an equilateral triangle, and we had the apothem, right? So this, we had the apothem. The given was the apothem. This one, the given was the side. An easier way to think about this is just do 1/2 the base times the height. So we could just figure out like this. If this is an equilateral triangle, what do all 3 angles in an equilateral triangle have to be? So this is the 60, making this little one the 30. If this whole thing is 10, that's 5. What's now the height of this whole thing? 5 square root 3. And now we could just do this. 1/2 of 10 times 5 square root 3. We don't even need the apothem thing. We just do like a normal old triangle. 25 square root 3. So there's some thinking involved in these. Like I said, the least amount of thinking is 11 through 16. From 17 to the end, you're going to need to know, is it a hexagon or is it a triangle? What type of information are they giving you? And then what can you go find out with those, with that information? It's going to stick to triangles or, oh, there's a square in there as well. Let's talk about a square real fast. I forgot it was. We're not going to do the whole thing, but you don't even need to put this in your notes. It has a square. Let's figure out what one of those triangles would be in a square. Right? Let's zoom in on this. What would this angle end up being right here? So we gave a formula for that. What would we get for that angle? What's that? 45, right? Because it's 360 divided by twice the number of sides, divided by 8. And so that makes a 45, 45, 90-degree triangle, and you can figure out stuff from there, right? Also, remember with a square, you don't need that whole apothem thing. Once you figure out, you can just do like base times height as well. All right? So gets a little trickier with this one. That's it for our notes.